items and where we are. All right, so let me share screen because I think we've got just a few things to talk about. Today's 12th of March. Open Source Antibiotics Series 2. Here we are. So the first thing I was going to just mention is some of the SAR for this series. So we have been doing a lot of stuff with motifs a little bit like this, where we found that we need this chelating 2-pyridyl thing, and the you can vary this ring a little bit, and we've been playing with aromatic rings joined directly to this 5-membered ring. And we were having issues with toxicity that was tracking with potency, and we were having a ceiling on the potency. And then we've evaluated some molecules like this more recently from Laurie's compounds, and suddenly found that we have some potency and potentially a selectivity index, a decent selectivity index, but we need to confirm that. So the most important thing that's going on is that these compounds have now gone to Alex for potency, for toxicity evaluation, which is great. At the same time, the molecules that we evaluated for tox last time are going, I think, to Laurie, right, for evaluation in DNDI's toxicity assay. That's right, Dana, isn't it? That we are sending.
Yes,
right?
So I haven't confirmed that with Ben, I don't think, but that should be fine, provided we have enough material, I think.
Yes. I think that Laurie was offering some screening in the DNDI kind of pathway for toxicity and other things, it turns out. But one of the reasons for doing that is to sort of double check their toxicity assay versus ours, right? That was an email that she volunteered it last time, then she sent a follow-up email, and we said that, yeah, we'd probably send them directly to her and she can sort of install them in her assay and get them screened, which would be very good. So we're doing these 6 for tox here, and she's taking ours and she's doing tox and everything else with those compounds.
Will she also do the trip assay as well?
Yeah, I think that's what it is. Yeah, I think it's the sort of the assay that they've been doing for their TRIPS project. Yeah, which is fine. So we can sort of cross correlate and stuff. But I mean, at the moment, the most promising compounds are these. And I was looking at these last night and I was thinking, if these came from that DNDI project, then hang on, how do these relate to the previous compounds that DNDI sent us? Because my memory was weak, but I seem to remember that those compounds came through and they weren't very good. So I searched through them and found them back in issue 35, and it was these guys, right, that were sent. From there, and there were some conclusions from this, but they were a little bit tricky. We sort of found that some of these 5-member rings weren't working stuff, but the most interesting conclusions from these were these guys, I think, over here, where we've got the chelating 2-pyridyl motif, and we've got a bunch of other things going on, whatever, but we've got the nitrogen and we've got the pendant ring here, which is the kind of thing that we have in the compounds that we were just looking at. Oops, sorry, I've just lost the place. Hang on. These guys here, right? So it's the same basic motif where you've got the same ring system, the 2-pyridyl motif, nitrogen, aromatic ring. So I was thinking, okay, hang on a minute, what's going on? What have we learned here? And the thing we've learned, of course, well, the thing that this is screaming out is that when this is NH, it's no good, and when it's N-alkylated, we get potency.
Yeah.
Right. And I was thinking, okay, I should have realized that, and that should be foremost in my mind when I'm thinking about understanding the SAR. And so one of the issues, which I'm going to put on you, Dana, and Ed, because I think that Ed is back full time on with us on like from next week, is to I guess update the SAR on the wiki. Right.
Yeah, that's been on my to-do list for a while. I just haven't gotten around to it yet.
No, sure, I understand.
It does need to be updated.
It's like the least.
Same conclusion that you did with the alkylation, and there was that paper from DNDI and Takeda where the two lead compounds, there were the two lead compounds in the paper that were derived from cyclopentyl and tert-butyl isocyanide, respectively. I was thinking those are commercially available, so we can get, you know, Dana, if you're able to, you can get maybe TBUNC and cyclopentyl and do the one pot and then alkylate using ethyl bromide.
I guess the thing I'm trying to emphasize here is that we need to two things. One is just to make sure that we have all the SRM in place, and it's like the least glamorous thing of all to do. You know, it's the most tedious thing to aggregate the data, but we have to, because I think that's something very specific here. We have to make sure the tox window is there, so let's not get too excited. But certainly that's the most important thing. And the second thing, though, is that we need to start writing up the this is a paper anyway, because we've got to get something out. And so it's not a bad idea to start thinking about, well, what are the SAR themes for a write-up? And this is a clear case of something we learned from screening a bunch of compounds which were contributed.
Take the N-alkyl off and then potency goes down. Yeah,
Laurie, so you want to come in?
Good morning.
Hi.
Afternoon. Sorry I'm late. So I just on this particular point. So I actually sent Dana a file this week with a bunch of structures. So I basically went through and had a look at anything and everything that we have on hand here at Northeastern. And look, we don't have very many N-alkyls because that's something sort of relatively new that we've been trying. Having said that, we have a bunch of material that we could potentially alkylate. And so we're actually looking at the moment to see, one, which of those actually makes sense in terms of our SAR, like for Chagas and Leash, do we want to be N-alkylating those? And then the other part is as well, I could potentially get an undergraduate. I think I've got one coming in over summer. Who could potentially work on actually alkylating everything else. You know, kind of like a second tier priority list as far as.
I'm not going to be able to share my screen, but I posted in chat what I came up with from the Takeda D&DI paper.
Yep, but yeah, so I guess what I was trying to say is we're hoping to be able to generate some more. And so I'm just waiting, to basically start doing some of that. And I'm hoping to be able to post that on GitHub shortly, just with like a full list of everything that we are proposing to do.
Okay. Great. That's awesome. I mean, it does depend on the talks, obviously, but I guess, you know, the main learning, as they say, from here is that is a key motif. So there are other things we haven't tinkered with, as we were talking about last time, the substitution of the pyridyl. And some of these rings, in theory, could be productive for us because they've all been tested here with the free NH. So we don't know.
And so this next set will encompass some of that as well.
Right.
845 would be very interesting because that head group, that cyclopentyl amine head group, was in the most potent trip compounds.
This guy.
Yeah, but that doesn't necessarily mean that the activity is going to translate to.
Doubtful, but it's always worth a try.
Yeah.
These are, I mean, okay. All right. So I just wanted to emphasize that. I mean, in the sense that, you know, again, with paper, we're doing this with the open source malaria paper, you know, we're going to be selecting out some key things for the paper here. And, you know, these will all appear in the supporting information, obviously, but in terms of our understanding, we're zooming in pretty strongly on the N-alkyl at the moment. All right. So that's, I guess that's just to, you know, to flag up that's important, but that's great to hear, Laurie. Thank you. And thanks to Anthony for the thing in the chat window. That's great. All right. So so these compounds are now with Alex. I guess we'll have to have an update at some point next week about, you know, what the time scale is there, because that's kind of a crucial experiment. I don't think Alex is committed to a time frame here because, of course, she's busy with lots of other things. But do you have a sense of it? I mean, last time it was a couple of weeks, right, at least.
Yeah, I think this time it should be quicker because they've got the cell line up and running and they don't have to
Right.
validate the assay and things like that. So I'm hoping it'll be quicker, but I can check in. I just dropped the compounds off yesterday. So I'll check in with her maybe end of next week to see how she's going. And I did tell her that we wanted to start with, I think 983, which is the one that showed that it was way less toxic in the MRC5 assay. So I thought that would be an interesting one to start with.
Good. Separately to that set, Flavio can't join us, posted some stuff last time of compounds. So there's some compounds that he's looked through in this Excel sheet that he's posted, and some other compounds that he can sort of derivatize fairly quickly based on the project that he was doing. And so the thing that strikes me about some of these, and it's great he did this. I think I've hang on. I'm gonna have to switch windows. Wait a minute. Zoom doesn't perceive that I'm no longer looking in that space. So the things he posted here, loads of data in here, really good. But essentially, I think all of the compounds do not possess the methyl chelation possibility. So they're all basically pendant phenyl rings. And so I'm not sure any of these are worth looking at, to be frank. Just because we kind of know that when we're unlikely to get anything. And of the, so that's the first thing. Of the other things, let me just go back to the original screen, which I think is that one. Of the other things here, again, the rings that he's thinking about functionalizing don't offer much, maybe apart from this guy down here, offer much of a methyl chelation possibility. So I'm just not sure it's worth our asking him for samples or further chemistry there until, I mean, it seems like a plan B is to sort of start branching out to other things, even if samples are available. I guess we shouldn't, we shouldn't get too distracted, is my sense.
We haven't tried, though, the final piece, I feel like, to put the 2-pyridiol to bed, which is an alkylated compound with phenyl or 4-pyridiol in place of the ring that we normally would need, the 2-pyridiol.
Okay. Yeah, no, sure. So, but I guess changing one thing at a time for me is fine. Would be fine if we want to revisit the pyridyl thing in the presence of another part of the molecule which we know is potent. That's fine. But some of these I think is just stepping too far.
Yeah, these are very far hops. So most of these.
Now the counter thing is I think that Flavio is happy to take our sheet and screen through the master list and see if there's anything that's of interest to him. But that, I guess that's on, I mean, we can provide those compounds, but that's on him to request them if he'd like them.
You may have to reach Twitter.
That Google sheet should be up to date, even if I haven't. I've tried to be good about updating that, even if I haven't updated the wiki. So that should be fine for him to look through.
Cool. Oh yeah, I had a question about that. I was looking at the sheet, and of course the sheet, the master list was designed initially for the fragments that we had. I may have been going crazy, but I didn't see a column for potency.
So the first tab is just a list of all of them, and I think it has like the Inchi key and things like that. And then there's other tabs down at the bottom, and that's where the data is. So the series 2 tab should have all the tox data, any ADME data that we've gotten from Lori or elsewhere, and everything, and the potency as well.
Okay, right. It was a little bit late in the evening, and so I missed that.
Yeah, so it probably would be most beneficial for Flavio to look through just that subset, which is in the other tab.
Okay. All right, great. Okay, so those are the main things. We're getting the talks done, and we're formulating compounds to send to you, Laurie, and we're I guess updating the SAR so that we are able to make sure that we're focusing in the right direction. That's all good. The mechanism of action is stalled until we get a better sense of that selectivity index. And the in vitro PK, Denny, you're busy with lots of other things, but eventually the HIFA sample will be looked at. I mean, that can wait for the moment. So of the things I want to talk about, that was everything. On the mechanism of action stuff, Giada, you've been looking at potential targets. Have you got anything you want to say? I'm going to put you on the spot. Have you got anything you want to say about modeling you're looking at with molecules that look like they're collating metals ions in the middle of metalloenzymes?
Yeah, I'm trying to do the docking again, and maybe trying to understand if the program that we are using is good enough to recognize chelating molecules. And I asked to some experts regarding this, and maybe I can try to change some commands in order to make the program to improve the program, and set this in order to make it better in order to chelate regarding the chelation. And yeah,
Yeah, I mean, I think that the issue we were talking about when we met last time was if you've got a metal ion in the middle of an enzyme and you've got a chelating motif and you bring them together, is it the case that the software immediately recognizes that there is a chelation event and it sees that as being quite important? And I think we were talking about you taking an example of a PDB structure where there is a motif chelating a metal ion, essentially taking the small molecule out and then putting it back in and check that it works. So that if you then in future start to model some of these suggested proteins that we've been interested in, then you would have confidence that if the program did not said that our molecule did not bind in that way, then you'd be confident of that prediction. Basically stress testing your method, right?
Yeah, also because I'm not really sure that the program is good enough, and maybe I should change some settings in order to have a better interactions with metals. So I'm checking it, and yeah, I'll
Cool.
let you know, of course.
Great. All right, that was everything I had. Anything else anyone wanted to raise?
Did the purifications come through? Benzimetazoles?
I've got a couple of them to come clean. So yeah, my plan for next week is to keep working on the ones that I had made that just were not pure, and then do some of the one-pot chemistry with those heterocycles that we had discussed previously, like back in December, January.
All right, great. Thanks everyone for joining. Laurie, we'll be in touch about molecules to ship to you following your very kind offer, and we'll take that off this meeting. All right, thanks very much, everybody. Really good, and stay in touch. See you next time. Have a good
Thank you.
rest of the week.
Bye.
Bye.
Enjoy the weekend.
Bye.